Hi students, in this video we're going to continue the problems on the projection of straight lines. So let us consider the problem. The top view of PQ of a straight line is 70 mm and makes an angle of 60 degree with XY line. The end Q is 10 mm in front of VP and 30 mm above HP. The difference between the distance of P and Q above the HP is 45 mm. So draw the projections and determine its true length and true inclination with HP and VP. So this is the problem they given. So as I said in the earlier video, you have to identify whether they given the true length or apparent length first, and inclination whether they given the true inclination, apparent inclination, and which position they specified with respect to the points that you have to identify. So in this case, this clearly specified the top view of PQ means the top view is given as 70 mm and makes an angle 60 means they given the apparent length and apparent inclination, and they given a position of end Q as well as end P with respect to only HP. So from this what exactly can solve, you will see that. So let me take the XY line first. So I'm going to take XY line. So I'm going to specify the X as well as Y, and I'm going to specify the quadrant by specifying VP and HP position. So once you specify, so first you identify the position of the given point. So the first point that's specified is the Q position. It is 10 mm in front of VP, 30 mm above HP. So I'll go for offset option, select the line. So I'll go for 30 mm with a single. So they specify 30 mm above HP, so it has to be on the VP side. So I'm going to go for vertical plane. I'm going to specify that, go for small dimension and specify the distance 30 mm. Next I'll go for the second condition they given, which is 10 mm in front of VP. I'm going to select the XY line. So I'll go for distance as 10 mm, enter. So I'll go for the HP plane. I'm going to specify that. So once you specify the dimension, that is 10 mm. So once you've done this, I have to define that. So I want to define this as locus of Q dash because that is the position of Q. So again I go for locus of Q. So once you specified, select any of the point on the locuses of Q dash and Q and specify that particular point as Q dash and this one as Q. So now the Q dash and Q has been fixed, that is the position of Q has been fixed with respect to the problem. Now the P has to be moved based on the given condition. They given one more condition that distance between P and Q is 45. So I have to take the one more offset option and this distance I want to write for 45 mm. That is the difference between the P and Q. So I'll go for 45 mm. So I want to take 45 mm. So once you take on that line, so I want to define that line as locus of P dash. Now this has been done, so I can show the dimension also. So now I'll come back for the length they given. They specify that the top view. So top view has to be drawn on HP plane. So that is length is 70 and angle is 60. So I want to select the line option. So go for Q point. So length I want to specify 70 and it is going downwards. So I want to take minus 60 degrees. So once you got that, draw the locus on that particular end point. That locus I want to specify as locus of point P. So now on this point I'm going to specify directly as P point. So now the PQ is nothing but the top view. So that line I'm going to give the thickness of 0.5 mm because that is the top view of the given line. Now once the top view is given, we know that Q dash and Q are in straight line, that is nothing but the end projector. Similarly P dash and P should be in a straight line. So P I going to project. So I want to take the end point of P, I want to project directly into the line. So that gives me the point P dash. So I got both the front view and the top view. So I want to join that. So P dash to Q dash, and this line also I want to make that as thickness as 0.5 mm because that is the view. So two views has been done, that is the front view and the top view. So now I have to get the true inclination, the true length. To get that, just it is opposite to the previous video what I explained, where I was done with the true length, then I gone for the apparent lengths. Here I'll go for arc by center point. Q dash as the center, P dash as the radius. I want to draw the arc. Similarly, Q as the center, P as the radius. I want to draw the arc. Now, the line which comes, that is the arc which I draw from P, I want to specify this point as P1 and this I want to specify as P2 dash. So once you've done that, from P2 dash, I want to draw a vertical line onto locus P and similarly from P1 to locus P dash. And this particular point, I want to specify that one as P1 dash and this point I want to specify as P2. Now, the rotation has been done. Now, I want to join from Q dash to P1 dash and Q to P2. So, there, when I want to get the dimension, this if these two lines having the same dimension, then the projection what I done will be correct. So if you had any mistake is there, just you have to cross verify with all the lines which you drawn. You can zoom that particular point where you join. If any mistakes is there, it is only because of the improper connection of the lines. So select the lines in a proper way. So once you've done this, I have to show the dimension. Go for small dimension, and this true length is 83.22, and here also I'm going to get as 83.22. That means what the projection we done is correct, and what are data they given is this they given as 70 mm and the specified angle also. So this angle they given as 60. What data asked? True inclination also have to find. So go for again angle between. So theta will be 38 degree and pi will be of 47 degrees. So this is the values we're going to find. So this is just opposite to the previous problem where they given the true length and you calculate the apparent length. And in this problem, they given the apparent length and you want to calculate the true length and the true inclination. The next problems we'll see in the next video.